Let's graph y equal negative x squared minus 2x plus 3. The first thing I'm going to do is find the x-intercepts, and I'll do that by letting y be equal to 0. So 0 is equal to negative x squared minus 2x plus 3. To make this easy to solve, I'm going to multiply both sides by negative 1. 0 times negative 1 is 0, and I have x squared plus 2x minus 3. Factoring this, I have x plus 3, x minus 1. That gives me an x-intercept of negative 3 and another x-intercept of positive 1. So on my graph, I'll go to x equal negative 3, 1, 2, 3, y equals 0, and then x equal 1, y equals 0. Now, this is going to be a parabola that will come down and go back up, or it will come up and go back down. Now, if you've done the reading in the book, you know that when this coefficient is negative, we have a parabola that opens down like this. Now, we can expect to find the vertex halfway between these two intercepts right here, or at x equal negative 1. Let's check that with what we have in the book for finding the vertex. When it says the vertex always occurs or has an x-intercept of x equal negative b over 2a, which in our case will be negative negative 2, the opposite of negative 2, divided by 2 times negative 1. So I get 2, positive 2, divided by negative 2, which is in fact negative 1. So that tells me that the vertex is going to appear somewhere on this line, x equal negative 1. To find the y-coordinate at this point, I substitute x equal negative 1 back into my original equation, and I get y is equal to negative negative 1 squared minus 2 times negative 1 plus 3. Negative 1 squared is 1, the opposite of which is negative 1. Negative 2 times negative 1 is positive 2 plus 3. That is y is equal to 4. So x is equal to negative 1, y is equal to 4. That's the x and y coordinate of my vertex. So x is negative 1, y is 1, 2, 3, 4. So I get a parabola that's going to look like this. It's going to come down through there and then also through there. So this is what this is a rough sketch of this. It would be easier to do if I was using a pencil and some graph paper. But I graph this parabola right here by first setting y equal to 0, finding my x-intercepts, and then finding the x and y coordinate of the vertex by using this formula, x equal negative b over 2a. So if I have these two intercepts and the vertex right here, then it's pretty easy to make a nice accurate sketch of that parabola. Let's look at another problem. Here I have y is equal to negative 2x squared plus 6x minus 5. Let's find the x-intercept by letting y be equal to 0. Negative 2x squared plus 6x minus 5. Now I can try to solve this, but if you check the discriminant, b squared minus 4ac, we'll get 36 minus 4 times negative 2 times negative 5, which is 36 minus 4 times 2 is 8 times 5 is 40, and a negative times negative is positive, so that comes out 36 minus 40, which is negative 4. So my discriminant is negative, meaning that I have two complex solutions to this equation, which means this graph will not cross the x-axis. So what I need to do is go right to the vertex and find x equal negative b over 2a, which is negative 6, over 2 times negative 2, which is negative 4. So I end up with 3 halves. To find the y-coordinate of the vertex, I take this x equal 3 halves and substitute it back into the equation. Negative 2 times 3 halves squared plus 6 times 3 halves minus 5. Now I'm not going to show the arithmetic on this, but I'll just show you what we get, which is x equal, or y equal, negative 1 half. Now if you want to check the arithmetic on this, you can, or you can look in the book. It's given there. It comes out y equal negative 1 half. So the coordinates of my vertex are x equal 3 halves, y equal negative 1 half. So if I go up to my graph here, x is equal to 3 halves, which is 1 1/2. Y is equal to negative 1 half. So I get this point right here as the vertex. Now, I know the graph isn't going to go back up, or I would get x-intercepts. So that graph comes down from there. To see what its shape is, let's let x be equal to 0 and see what the y-intercept is. So my next step is I let x be equal to 0, and I have y is equal to negative 2 times 0 squared plus 6 times 0 minus 5, which is minus 5. So the y-intercept is negative 1, 2, 3, 4, 5. So from this point down, I go back to here to get that point. If I go the same distance in the other direction, because of the symmetry of this parabola, I'll have another point on the graph. So my graph looks like this. Or this is, I should say, a rough sketch of this graph. So here we've graphed a parabola that does not cross the x-axis. So in this case, I didn't even have any x-intercepts, but it's still okay. I just noticed that I'm not going to get x-intercepts here. So I go ahead and find the vertex. I know the graph opens down from there, so I just find a convenient point on one side of the vertex, and then by symmetry I have a point on the other side, connect those 3 points, and I have a nice, accurate sketch of the graph of that parabola.